Maya's jaw is tight, and her breathing is shallow. Her phone has been vibrating with notifications since 7 a.m., and her brain is struggling to process the data. This mental fog is a symptom of directed attention fatigue. Urban environments force us to filter out traffic noise and flashing screens, a process that drains the glucose and chemical resources the prefrontal cortex needs to maintain focus. She silences her phone and steps off the pavement onto a dirt path. The concrete grid falls away behind her. Natural, unfiltered sunlight hits her retinas. This specific light spectrum communicates with her brain's suprachiasmatic nucleus to synchronize her circadian rhythm and regulate her internal clock. She takes a long, intentional breath. This stimulates the vagus nerve, which signals the heart to slow its beat. Within seconds, her body shifts from a high-alert sympathetic state into a restorative parasympathetic mode. Crossing the threshold into the park triggers a systemic biological response that continues to unfold as she moves deeper into the trees. A quarter-mile in, the sharp angles of glass and steel are completely replaced by the organic, curving lines of the forest canopy. As she moves away from the urban center, her cortisol levels drop precipitously. This measurable decline in stress hormones marks the beginning of her physiological recovery. Her eyes begin to track the fractal patterns found in branching trees and leaf veins. These are complex, repeating visual geometries that occur throughout the natural world. The human brain is evolutionarily wired to process natural fractals effortlessly. By simply observing these shapes, the visual system rests, actively reducing the mental fatigue accumulated in the city. Attention restoration theory calls this state soft fascination. The swaying canopy holds Maya's attention gently, without requiring her to make decisions or respond to alerts. By looking at the forest, Maya has allowed her brain's executive function to enter a state of active recovery. While her mind resets, her lungs are facilitating a specific chemical exchange with the forest itself. Trees release invisible antimicrobial compounds called phytoncides to defend themselves against rot and pathogens. Studies show that inhaling phytoncides like alpha-pinene triggers an immune response. This chart illustrates a significant spike in natural killer cell activity, which targets tumors and infected cells after a few hours. These anti-cancer proteins remain elevated for over 7 days after the trip. Maya notices the scent of the damp earth. She is inhaling the soil microbiome, including a common bacteria called Mycobacterium vaccae. Inhaling this soil bacteria stimulates the human immune system to produce serotonin. This effectively turns the forest floor into a biological antidepressant, regulating her mood through direct contact. Maya is walking through an active biological laboratory. These trees are effectively engineering her blood chemistry with every breath. Maya sits on a park bench. She doesn't reach for her phone. She lets her mind wander as she watches the movement of the clouds. This lack of an external task activates her default mode network, the brain state utilized for introspection and self-reflection. As the rigid focus of directed attention powers down, a wide, interconnected web lights up across the whole brain. This unstructured state untangles mental blocks and improves creative problem-solving performance. Maya stands to head back. Her posture is relaxed and her mind is tranquil. Lower cortisol and elevated immune cells represent our intended biological baseline. The forest provides the environment. Our anatomy does the rest.